Okay, welcome to today's video where we're going to be doing a follow-up on the CH341 Alpha. So it's the black one. There are a couple of different revisions of this thing, but this one's the black one that I have, and we're going to just follow up on that because I've kind of felt guilty about not following up on it. It's one of my most popular videos on YouTube, and the thing really is not very good. It just to put it blatantly, it's not what I intended. Like what I purchased it for, it does not serve that purpose. Therefore, to me, it's pretty useless. Plus, mine broke after just a couple of uses. I didn't do a follow-up video immediately though because it's in part my fault it broke. I was being negligent in my usage of it and damaged it. So I never did a follow-up video because I kind of felt guilty. I didn't feel like it'd be fair to really criticize this thing when, in part, it was my fault it broke. So yeah, that's why I hadn't done a follow-up until now. But at this point, I've decided it's important to do a follow-up video on this thing. So the too long didn't read of this video, that I'm not going to watch the whole thing, is this thing is inherently dangerous design that could damage your computer. That's really the sum of what this whole video is about. Is we're going to look at this, we're going to see why this thing is dangerous and can damage your computer. It almost damaged my computer, and that's really what I want to talk about. We'll talk about some of the other design flaws, but that's not really the point of this video. So yeah, let's get an overhead look at this so we can take a better look at the actual damage going on here, and then we'll discuss, we'll do some testing. All right, so here is that CH341 again. So I got the schematic pulled up on screen, so we'll discuss it real quick, but I just want to talk about why this is inherently dangerous. So this thing does not have a fuse. So we'll take a look at, we have VCC coming out, so we're looking at the schematic now. We have VCC coming out of our USB drive, and it goes through a 0 ohm resistor, and then it comes over here. So we have no resistor network protecting the data lines here, nothing, no isolation on our data lines or anything. So if for some reason we were, say, overvolt, you know, we plug into something, oh God, we accidentally plugged into 12 volts, overvolted it, shorted out the CH341, and now we got 12 volts going across the data lines or going directly into your computer, and that's it. You know, there's nothing stopping that from happening. We have no isolation on our USB port at all. The other problem we have is we have no isolation at all on our data lines between the CH341 and the ZIF socket. So that's actually what damaged mine, is that zero isolation there. I made a mistake and I accidentally clipped to the EEprom incorrectly and shorted all my pins together, and I just had 5 volts going directly into those data lines unimpeded. There was no resistance, and it damaged my CH341 and tried to take my USB hub down with it. I'll explain that more in a moment. But yeah, so we're looking at the schematic here. So here's another problem. A lot of people addressed it in my video that I did. It was something I didn't think about because I just simply don't use this thing for 3.3 volts. I only do 5 volts, so I didn't think about discussing it. But they made a very good point, very important point to make, is if we take a look here, so we have our VCC, and it goes to 5 volts, goes directly to 5 volts. And then I showed this, you know, the voltage regulator, when you get that 3 volts, it only goes to the 3.3 volt lines. It doesn't go anywhere else. I showed that in the video. So what that means is that VCC is also going directly to our CH341 alpha right here. VCC, that's what's going in. Guess what? This CH341 alpha, when you are doing data, when you're reading and everything, those are always at 5 volts. The data lines are always 5 volt lines on this chip. So that means if you are using this in a 3.3 volt application, so okay, yes, you're supplying 3.3 volts to your VCC line, to your EEprom, you're still supplying 5 volts to the data line. So hopefully that EEprom you're trying to read is a 5 volt tolerant 3.3 volt EEprom. Elsewise, you could damage the EEprom. And on top of that, if you're using this in circuit, that's a really bad idea, because although your EEprom may be 5 volt tolerant, your microcontroller may not be, and those data lines are going to see it on both sides, so you could damage that microcontroller. So that's something to be aware of, is this is really bad for 3.3 volt applications. I would recommend making something similar to this for your 3.3 volt. This is a 1.8 volt adapter for this that just does a level shift on everything. You just make the same thing for 3.3 volts instead of, you know, modifying the whole thing. There are videos about how to modify this to do to do 3.3 volts on the data line. I don't know. I don't recommend this tool. Although I have to say, for $2, you can't beat it price-wise. But you need to be aware of everything going on with this. So be very aware of what you're getting for that price. So yeah, we 0 protection for our USB drive, and we have 0 protection for our ZIF socket. So those are really the big flaws with this thing. The other flaw is, okay, so we don't protect our data lines for either of these. We also are not protecting our power on our USB drive. A 0 ohm resistor is not a fuse. People like to use them in that sense, but they are not fuses. Fuses are designed to blow, either slow blow or fast blow or self-resetting. You have all of those options. You can have a self-resetting fuse, you can have a slow blow or fast blow. In this kind of situation, I'd probably want a fast blow fuse to protect my USB port. A 0 ohm resistor is as far from a fast blow fuse as you could get. Self-resetting would also be a good choice here. I wouldn't go with slow blow unless you kind of underrated it. Then maybe. But yeah, I don't know. It's hard to say what kind of fuse I would use here. I would actually probably design this with, they make USB isolation chips, and you can just put a USB isolation. You have to make this whole thing a little bit bigger, but have USB isolation before your CH341. So that way, if something goes horribly wrong on this side, it doesn't see any of that on the other side. That's really how this should have been done to protect your computer. Because it's going to be a big shame to plug this into your $2,000 MacBook and fry the USB on it. Well, USB-C, I don't know. You'd have some adapter there. I don't know. I wouldn't plug this into an expensive... Okay, so real quick, before we take this 0 ohm resistor off and see how long it takes us to blow it. Actually, I'll probably just blow it on here because I don't care about the rest of this board anyways. But yeah, this is what happened. So what happened was I believe I was using the clip. I may have been using the bed of nails. But yeah, I had it in that position, normal setup there. But when I clipped onto the EEprom, either way, whichever one I was using. So let's say the tip of this pin is the leg of the EEprom. I clipped it like this, where it was in between the two pins instead of directly on it. I just misaligned it, clipped it on there like that, and I let it sit there for a second because I thought I had it clipped on right when I put it on there. I clipped it on, and then I turned around and I was working on the computer, getting the software loaded up because I hadn't already loaded it up, but I did already have it plugged into the computer. So in that time, it gave it a significant period of time to continue to run that shorted out current, because this thing always has 5 volts on the 5 volt line or the 3.3 volt, whatever, whichever mode you have it in. Your supply line is always hot on this thing all the time when it's plugged in. And so that was where I was in the wrong. I shouldn't have had it plugged in while I wasn't attending it. I should have attended it the whole time. I didn't walk away, but I still was distracted using the software instead of paying attention to what I was doing there, and gave it plenty of time to get hot enough to crack this open, let out a small spark, and smoke. And that was it. So yeah, this guy cracked open, and don't go, oh, you overvolted it with, no, it was on one of these boards on my workbench, not plugged into anything. It was just basically, this isn't the EEprom, this is a parts board, but it was basically just sitting there like this, and I was unattending, and then turned around and saw spark. Well, I heard I heard the spark, turned around, saw the smoke, and a little bit of a flash there, and that was all I got. I wasn't actually clipped to this chip. This is a voltage regulator. The EEprom's just, well, the EEprom's just not on this board at the moment. See, it's a parts board. Just use it as an example. But yeah, so that's basically what happened to fry and kill my CH341. Another thing that's really inherently dangerous about this is it doesn't come with a housing, which, okay, fair enough, it's cheap. Coat the back with conformal coating. I coated the back of mine with conformal coating. But yes, coat the back with conformal coating before you ship these out to people, so that way it at least has something to probably protect it from shorting out, you know. These lines are just exposed here, so say this is sitting there and I just sit it across it, and there now we have a dead short across all of the pins there. So I don't know. Not the most computer friendly design. I get it. It's $2. Fair enough. They just copied somebody's open source design and sold it. Fair enough. But I don't know. Have some level of protection for the end user's computer. I would rather pay $4 for it and it have some level of protection than pay $2 for it like this. I'm telling you, this thing is cheaper than the ZIF socket that's on it. I don't know how they make money at it. I mean, yeah, I paid $10 so that way I would get all the adapters and stuff with it. But still, even at $10, I got 2 ZIF sockets. These things are like $5 a piece if I try to buy them individually. So it's still cheaper than the chips on it. I don't understand it. So let's get this let's wire this thing up real quick and see if we can let the magic smoke out of it. Okay, so here you can see the setup. Just got it wired into the resistor directly, and then the power supply up here, and it is one continuous wire here. I'm not faking this and hooking it up to some battery or something. So let's go ahead and turn on the power supply, and we'll start with something a little bit closer to what you would expect to see from a computer. So 5 volts, and then let's go down to the amperage, and let's just go to 1 amp, which is actually much higher than you would normally see on a USB. So on a USB 2 port, this is way over what a USB 2 port is rated for. USB 2 ports are normally rated to half an amp or 500 milliamps, and then USB 3, just a regular USB 3, is rated to 900 milliamps, so just under an amp. And then the charge dedicated ports are actually rated to more like 1.5 amps. But yeah, so this is more than what you would see on a regular USB port. So let's go ahead and just try that and see if it blows, which, oh, we are on the wrong one now. Okay, so there we go. Now we're set on the right one. And so, yeah, so we're going to power that up. And again, that is significantly more than the up to 1 watt that resistor should be rated for. That resistor should be like a 3/4 watt resistor. So let's power that up and see if it blows. All right, so we have about half a watt going through it because it's that constant current of 1 amp is going to drop that down. Knew this was coming, just wanted to demonstrate that. So yeah, keeping it at a constant current of 1 amp, we're really getting that. So yep, we're gonna go up to 14 volts now, and that didn't blow it. Let's see what we get here. So, oh, we didn't change it. There we go. That's gonna put 4 amps through it. So now we have 5 watts going through it. It's not blowing yet. Still not blowing. It's still going. All right. So, yeah, that doesn't blow it either. So let's go ahead, and really the voltage doesn't matter because we're going for a constant current with this device, not a constant voltage. So let's go ahead and go down here, and we're going to go to the max I can get out of this unit, which would be 9 amps. 9 amps going through it. Let's see what happens. We have 9 amps. That's 21 watts going through that resistor. Has it blown yet? No. No, it hasn't. It still hasn't blown yet. Still not gone yet. So, do you trust a 0 ohm resistor as a fuse. I don't. This is getting hot, but it has not blown yet. This is not a fuse. Don't trust 0 ohm resistors as fuses. This will eventually burn out. It will stop working. Just because it's rated to 3/4 of a watt doesn't mean it's going to immediately die if it sees more than 3/4 of a watt. It's just not rated for continuous use at 18 watts. So, yeah, this isn't going to blow anytime soon. We're going to let this burn for quite a while before it blows, and I'm not going to bore y'all with waiting this whole time. But yeah, 10 amps is the most I can get out of this power supply. That's its rating. All right, so I'm gonna go ahead and turn that back off. Let's see what all is getting hotter though. Even the wires are getting warm. These wires are significantly warm. Yep, the back of the board's pretty warm. It's not so hot that it's burning me, but yes, we just ran 10 amps through that resistor, and it did not kill it. If I had a car battery laying around, I would hook it up to it, and we could see how long it takes to blow. But I don't have one laying around. I just wanted to demonstrate for those that believe a 0 ohm resistor makes a good fuse, you're incorrect. People use them as fuses all the time. It's just a bad practice. You should not do that. Don't count on that 0 ohm resistor as a fuse. Okay, so before I just go out and say this thing sucks, I do want to give it credit. At $2, you can't beat it. It's a great price. Just be careful with it. That's what I want to say there. It's not total garbage, but I don't recommend it. You just can't beat the price. All I have to say there. So if you are on the world's tightest budget, this is the tool for you. You just might damage your computer or whatever you're working on. There's zero protection there. There's no decoupling. There's nothing really protecting, from ESD or from, this is inherently dangerous by design. So you ask, what do I recommend? I really like these Mini Pro programmers. They're not the world's best programmer, but they're good. Now, mine's really old. It's actually a genuine auto electric one, but it's old, and it is the TL866CS. So this is before version 2 came out, and yeah, it's pretty old. It's probably 6 or 7 years old. It was right before they discontinued this line that I got this one. They came out with the version 2. The version 2 has been discontinued for the 2 Plus. And then the other, I forgot what the other new one is. The newest genuine one is around $100 for it. Or you can get the clones of this one for about half that price. I think they're about $50 for the clones. They may have gone down even further in price. I can't remember. I really don't follow the clones of this, but the genuine ones, it's a good deal. The software works good, in my opinion. I like these. What I really like about these is they can also test TTL chips. So that's a huge plus for me because I work on old stuff that still has TTL logic in it. Does this do in-circuit programming? Not mine. You can modify it to, though. You can do modifications to it. Biggest takeaway on this one is the Windows software for it is very sensitive to putting it into overcurrent protection. So it's pretty difficult to use this one in circuit. The Linux software for it is less sensitive to that, if it even works. I don't know if overcurrent actually works on the Linux software. So it doesn't go into overcurrent protection as much on Linux, and then you can use it in circuit. There are also modifications to make, I think you modify the shunt resistor for the current sensing, and you can get a little bit more current out of it and do that. But then you're kind of taking away some of the safety features of this device, which is why I like it, is I've not damaged anything in the 7 years I've had this. This one lasted me maybe a month on my workbench before it tried to kill my USB hub. The only reason why my USB port is not dead on my computer is because I was going through a powered USB hub. So that USB hub was able to provide enough power to not get damaged. Had it been one of the ports directly on the motherboard, I would have blown one of the fuses on the motherboard and had to repair my motherboard. So I'm glad I was using it on a USB hub when this happened. And yes, having it on that powered USB hub is definitely why it had enough current to actually let that magic smoke out the way it did. I don't think it would have burnt up quite as bad. I don't think it would have been able to scavenge as much power had it not been on it, but it still would have scavenged as much power as the port would have provided, and then it would have blown the fuse on the motherboard. So that is my problem with these. Yeah, I really liked this thing at first because of the price. I was like, yes, this is great. Anybody can afford this thing. I want to highly recommend this to people to get them to get started, because that's the biggest thing with EEprom programming and any of this kind of stuff in electronics. It's really hard to get people started in this. So I was like, yes, this is great. I can get people started on it, and then they'll move up to better tools in the future. Now, I kind of second guess that judgment of saying that this is a good starter tool. All right, well, hopefully my follow-up to that old video makes sense and isn't too much of a rambling. I know I kind of go one way of, oh, this is a bad device, and another way of, but it's super affordable. And that's really up to you to decide. Do you care about the safety of your hardware, or is your budget so tight and you really need to get started? And that is for you as a user to make that risk assessment and decide what you want, and if you want to just spend the extra money on something that's not going to damage your computer. I'm sure there's going to be a lot of people that come in the comment section, I've been using this thing for 2 years and I haven't damaged it. Good for you. But we've gone over and shown in the schematic, there is nothing protecting your computer. There's no isolation. There's no fuse. There's no isolation on either end. There's absolutely nothing protecting either of the sets of data lines on here. So I mean, just the facts are the facts. This thing is inherently dangerous. It also doesn't actually do 3.3 volts like it's advertised. It really only does 5 volts. You can just change what the supply power is. And also, as my original video goes, you don't have to modify this to get 5 volts out of it. I don't know why that person believed you had to modify it to get 5 volts out. You just plug it in. You get 5 volts. Well, it's this one over here, I believe. Yeah, put your jumper in right there, and there you go. You have 5 volts. You still need that jumper there, but you get the point. So I recommend something more like this, but it is up to you. I will have links in the description for both the newest version of the Mini Pro. They don't sell this one. They don't sell genuine ones of this one anymore. So I will put a link to a genuine one of the newer version, and I will put a link to this, although I don't really recommend it. You make the judgment call of what you want, though. I know it works for some people. I know people that it does work good for. I just want to caution you to protect your equipment that this thing's not that safe. So yeah, take it how you want. So I hope you guys liked the video. I hope you learned something, and I'll see you in the next one.